I believe that last recording got cut off a bit early, but essentially we did see that it was actually attempting to charge from this with over an amp. However, it's also drawing current. Okay, so what I've done here is I've actually connected it to the pin. So this one is the one that's common to both the charge and the discharge, because it's drawing power from this connection and this one, right? But then it's providing power to across these two here. So this one is common to both circuits. So we now see the actual contribution, okay, in terms of charge current, and it's that. So that's the difference between the power it's drawing from the battery and the power it's providing to that cell. Yeah, which is what we expect. You know, we expect it. I think I expected it to be, well, if it's putting in an amp, you'd presume it has to draw about a third of an amp because it's 3 cells. So that's, let me see, okay, so that's 0.41. What we got on here? Because this is the other way round. Okay, oops, there we go. Okay, so that's actually 0.83. That's weird, but there we go. I'm trying to reset it. There we go. And now let's try and get it in there. So that's saying 1.02 is negative because it's going through the meter the wrong way. Okay, let's just verify it against the positive one as well. Yeah, you see that says 0.9, so I'm not quite sure. It's really difficult because these meters are not that accurate. I can tell what the power is being drawn by putting it across that. There we go. So that's the power that's being drawn, 0.41. Okay. So the power that's being put in is here, and it says, yeah, you see it varies as I move it around. Yeah, I'm trying to get it in. It's possible because it's near to the meter. Oh, you go 1.1, right, 1.12. That's what it's putting in, right? And the average power is, there you go, sort of 0.4ish, isn't it? So the actual charge rate on that cell is that 0.4 amps. That's right, isn't it? I think so, yeah. Yeah, because this, okay, let me just put that down. This is drawing power out through this wire in order to power the charging circuit, the cell balancer, right? And this part here is putting current, yeah, because you can see the red wire there. Okay, it's putting power into it. This is the negative, this is positive. So current is going that way from this buck converter, but this is drawing power, so current is going that way. So when we put a meter on there, we see the average current of the two, which is 0.4. Yeah, it's interesting. Very interesting. Yeah, I think I got cut off on the last recording. But basically, I'm going to monitor this. I'm going to leave it just running as it is, and we'll see how far it goes. See how well it balances, how quickly. It doesn't have to be quick. It's actually better if it isn't, in a way. It's better if it's slow, because then that means you can then get a better, you get a more efficient transfer, because you're actually only transferring a small amount. If you try and do it quickly, then I believe these circuits will basically become less efficient. So you're best off doing it with a small amount of current. 400 milliamps, I guess, on an average power is fine. Now, if I actually check the power that's coming in from the negative terminal, that's probably going to say a lot more, because it's actually drawing the power from the 3-pack. In fact, that's a good point, that. Let me see. Okay, so if I just try and set the meter up, DC, let's move this drink out of the way, and then we can see, let's move that, there, 0.5, yeah, so it's drawing 0.53 and it's charging at the rate of 0.4. So 0.4 plus 0.53 is 0.9. Yeah, I think that makes sense. I don't know. Anyway, yeah, it's interesting. Anyway, obviously, like I say, we can see on the graph this cell, which is the one that's the lowest, is being charged. Now I connected it to that cell, so it's not like somehow it's resolving which cell it needs to charge itself. It isn't. I'm looking at it and I'm doing it now, but the circuit would actually be target the cell, based on the lowest voltage. I'm just looking at the voltage going, oh, it must be that one, so I'll connect it to it, you see. And the police have come. No, they haven't.